we measure angles in two main ways, using two main units. The first is degrees, and the second is radians. Now, a degree is simply defined to be 1/360th of a complete revolution around the vertex. So if I draw a ray and I start to rotate that, okay, if I rotate all the way around, that's defined to be 360 degrees. I'll go ahead and draw that. Okay, this is 360 degrees. And so a degree is simply defined, of course, to be 1/360th of that. A radian is actually a little bit more intuitive as far as what it is. A radian actually has to do with a circle. So I'm going to go ahead and draw a circle here. And if I draw a ray, now this circle, okay, it has a radius. If I go ahead and draw that from the center out to the circle, okay, this is a radius r. Now that length right there, if I actually were to rotate this ray so that the length of the arc here, let me go ahead and draw that. If this length right here is r, okay, so we just rotate until that arc length is equal to the radius, then that is what defines for us 1 radian here. Okay, so this angle here now is 1 radian, and you can see that's how it gets its name, right? Radius, radian. And so that actually gives us this little nice relationship between the length of an arc S and the angle theta. Theta is that arc length divided by the radius. So when that arc length here is equal to the radius, okay, then when you divide them, you get that 1 radian. And we actually know that in a circle, we know the circumference of a circle is equal to 2 pi r. And what that tells us then is if we were to take that full circumference and divide it by r, okay, then you can see that the r would cancel here, and you would simply get 2 pi radians. 2 pi radians. And that's 1 full revolution. 1 revolution. So 360 degrees is equivalent to 2 pi radians.